Hello, today we are going to talk about scatter points and lines of best fit. And I am actually going to work on your third guided practice from our book in this section. All right. It kind of covers probably the most important parts or all aspects of this section as well as most of chapter 4, to be honest with you. So here's this problem. We're going to make a scatter plot. We're going to determine if there's any correlation. Okay. We're going to draw our line of best fit, so everybody's might be a little different. We're going to write an equation. We're going to make a prediction, and I guess we're going to make another prediction, right? Yeah. So let's get started. The first thing we want to do is to graph this. And the biggest issue most students have is when they give us years in this data, they think they got to put in 1996, 1997, but we can just set 1996 to year 0, and then we're just counting by 1 after that. So it'll look a little more similar than what you're used to. So I'm going to start with that. In fact, I'm going to get the graph in off screen here so that you don't have to watch me draw all this up, and then we'll go from there. All right, so I have my graph set up. I decided to count by 0.1 every time because it wasn't that many to get to 26, which is pretty close to our highest y value, so our range there, and 24.8. So there wasn't that big a spread of data. And then again, I used year 0 for 1996, and then the first year on my x-axis is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10. There we go. So I am now going to plot this data onto my graph. Okay, and you're going to see right away that the data is not linear. All right. So in 1996, the age was 24.8. So that is my year 0, and that's where I'm going to put my dot. Okay. And then in 97, it was 25. And 98, it was also 25. So I got those 2 dots. So I went from here. Plotted. So year 3 was 25.1. And year 4 and 5 were also 25.1. So now my data looks like that. All right. So year 6, we have 25.3. And that's good for 6, 7, and 8. If you see, it's the same value, 25.3, 25.3, 25.3. So that's 6, 7, and 8. So now we look like that. And then in year 9, it was 25.9. Nope, 25.5. Sorry, year 9 was 25.5. And year 10 was 25.9. So there is the data. All right. Now, it's clearly not a straight line, but we're going to try to draw a line of best fit. Okay, so what we're going to try to do is draw a line, probably through here. I want to be as close to most of those points as I can. And to be honest with you, I'm looking at this guy, and he kind of seems like an outlier. That's a pretty big jump, where the rest of these jumps really aren't that much. Like we kind of have a slope of, up 2 over 1, up 1 over 1, and then we have, again, this up 2 over 1 if you're looking at it from this point. And same thing here, and then we have a big jump here. So I'm not going to pay as close attention to that point when I draw this line. All right. I couldn't find a ruler, so I'm just going to use this pencil box as a straight edge. So again, I want to be, kind of like, I'm really not going to try to include that point very much. That doesn't seem like a very good representation. That line right there seems about right. I might go a little bit off. Maybe not. I think I'm going to go like this. And don't stress out. I'm just trying to make this look nice, but it's really not that big of a deal. So that looks like my line of best fit. You know what? And I'm pretty happy with that. So, again, this guy's pretty far away from the line, but the rest of these points are pretty well clustered. I have a few below, a few above. I think this is going to be okay. So, and the fact that I have more above than I have below, and we have this above outlier, so the fact that this data, here, might kind of rein that in. So we're going to see what we come up with. So it's our job now to pick 2 points along the line we drew to represent this data. And I'm trying to find the best points I can find. I don't want to get too crazy. Like, though, I almost looks like I went through this one perfectly. So I am going to use that data point, and that is 725.3. So one of the points I'm going to use, I guess I'll write it over here, 7 comma 25.3. And I'm not too far away from here. That looks okay. This one looks okay too. I may use this one. You don't have to use the points they give you, but since we're counting by just 0.1 here, like being off, like it's not going to make any point for me to be, try to get down to the hundredth or thousandth of a decimal just to try to be as accurate as I can. This should be okay right here. I'm going to use 425.1 will be my other point. All right. So those are my 2 points. And my job right now is to try to come up with the equation for this line. So just like we've been doing for the past couple of weeks, we're going to use the slope formula. Okay, so 25.3, I'm going to subtract the y values, and I'm going to get 25.3 minus 25.1 over, I'm going to subtract the x values, just be consistent, 7 minus 4. Okay, and that's going to give me 0.2 over 3. Okay, and when I do 0.2 divided by 3 in my calculator, I'm just going to call that 0.07. Okay, so the slope of my line is going to be that. Okay, now as far as how we're going to write our equation, you can use either one of the points you use for your slope and this slope, and we're going to put it in point slope form. So I'm going to use the first one because, I don't know, it's not that big of a deal which one we use. So y minus 25.1 equals 0.07 times x minus 4. Okay, I'm going to distribute, and I'm going to get y minus 25.1 equals 0.07 x minus 0.28. All right. Now the last thing I have to do is add this 25.1 to both sides. And that gives me 24.82. So y equals 0.07 x plus 24.82, which honestly 24.8 is probably all I should write down. So that is the equation for this line of best fit. Okay, so that's the equation we're trying to come up with that covers, for the most part, the trend of this data. So we can make predictions. Okay, so when I do that, if I look back at my questions here, we wrote our equation, predict what the median age of females when they are first married will be in 2016. All right, that is 20 years from 1996, right? So 2016 is 20 years away, right? We're 10 years here and then another 10 years in 2016. So we are going to put that 20 right there in our equation. And it's not going to change by much because our slope isn't too much either, but and to me, it looks like that will be 26.22. Okay, if this trend continues. Now, one thing you might want to think about, like there is a jump here. It would be nice to get actual data because maybe that trend is more up here now. You never really know. But that's what we're getting there, 26.22. And again, this is your line of best fit. So, our answers, our slopes may be very different. Our answers may be very different. But if you're going through this process, that's really the important part. Okay. And then the next one is 2056. So that's going to be 50 years, right? Yeah. Actually, it's going to be 60 years. So we're going to do y equals 0.07 times 60. So 60 years from now. And I'm going to do that math. and I end up with y equals 29.02. So the average age of marriage would be in 60 years, if we continued this trend on out, would be about 29 years old. And again, our answers can be different as we go through because we may have, maybe we drew a line out here closer to this data point, so your slope will be steeper. That would increase this age. And so we could all have something a little different. It's not a big deal, but this is essentially the process you want to go through when working on these problems. I hope this video helps, and I'll see you guys next time.